In this video we'll explore log levels, which are a fundamental concept in logging and in most logging packages. And log levels are a vital concept to understand as you develop, deploy and maintain applications. So let's dive in and explore log levels and give some examples of their usage. Now, log levels underpin all good strategies for logging in applications. And these log levels, they have labels that indicate the severity or the urgency of particular events that are occurring in your applications. And the typical levels that are used in modern software development are fatal, error, warning, info, debug, and trace. So why do we need log levels? When you have an application and when you're developing that application, you need to record different information about different events of different severity that are occurring in the process. And these events are not created equal. Some have great significance and could indicate a critical problem in your application, whereas others are more informational messages that can help developers and maintainers as they try and understand the behavior of the application. So not all events are equal here. So to give an example of this, on one hand you might have logs that record the status or the state at a given time in your application. And an example of that might be the value of a variable or the response data from an API endpoint. On the other hand, you also need to log information about events that have greater significance. And this could be about things like warnings and errors that are occurring in your application. For example, maybe some unexpected input from a user, or perhaps a critical problem. For example, the server may be running out of disk space. So you can create these levels to separate across these boundaries. And in addition to that, the use of levels also allows you to filter the logs as well. So for example, you can filter the logs that you have and only get back the logs with a particular level. For example, that could be the error level. Now, another benefit of levels is that you can send less important logs, for example, just informational logs, to a different location than the more important logs. And that allows frequent log rotation to occur on those less important messages. And such a strategy will also cut down on storage costs. On the other hand, logs that contain critical messages or information about a failure in your application or the infrastructure on which it relies, these will have a higher severity level and they can be sent to different handlers from those basic informational messages. An example of that might be an email handler that very quickly notifies developers and administrators about problems that are occurring in the application. So the levels allow you to separate the logs and filter those logs, and they can also enable analysis and alerting as well as anomaly detection. So that's the introduction to log levels. Let's now move on. We're going to look at a very brief history of log levels, and then we're going to move on from that, and we're going to show some practical examples of all of these levels. Let's quickly explore the history of log levels. We're going to reference this BetterStack article, which is linked in the description. And as it says here, log levels have a history dating back to the 1980s. And the concept of levels originated with the syslog standard, and these introduced the following log levels. We had emergency, alert, critical, error, warning, notice, informational, and debug. Now these map closely to some of the more modern log levels that are used in modern programming languages like Python, Go, and JavaScript. And in fact, if we scroll down a little bit here, we can see that some logging frameworks such as Log4j and Log4j, which are logging packages for .NET and Java, these frameworks recognize the significance of these severity levels and they further refined the concept. So in most cases nowadays we have the following log levels, and these are from most severe to least severe. So we have fatal, error, warn, info, debug, and trace. And we're now going to see some examples of these log levels and practical examples of when you might want to use them. For those examples, we're going to use Python, but this BetterStack guide has examples in different programming languages and also different frameworks within those languages. And we're going to start with the most severe log level and work our way down to the least severe, which is the trace level. So let's get started. We're going to start by looking at the fatal or critical log level. Now the critical or fatal log level, this is reserved for the most severe issues that can occur in an application. This level indicates a critical failure that will stop your application in its tracks. So typically you cannot recover from this. You're going to log the critical error and the application is then going to stop. Now some examples of critical errors include things like a loss of connectivity to an external source that your application depends on, and that could be a database or an external API. Another example would be running out of disk space on a server where your application is hosted. Configuration errors as well, if your application relies on some configuration that is not available in the environment. And also a security breach that could be considered a critical issue, and you might want to log that out at the critical level. Now, in order to demonstrate this, I'm going to go to VS Code, and we have a Python application here that imports the logging package, and it creates a logger object, sets the level to debug, and it creates a formatter that's going to set the format of the output entries. So we're going to have the time, the level, and the message in the output, and then we create a stream handler that's going to log to the console or the terminal, and we add that handler to our logger. So what I'm going to demonstrate here is something that might cause a critical error in your application. What I'm going to do at the top is import the OS module and the sys module from Python, and then underneath the logger we're going to attempt to import some configuration from the environment. And this is a standard practice in software. You want crucial configuration to be stored in the operating system environment. So in order to do that, I'm going to paste this bit of code. We're trying to retrieve a database URL by calling os.environ.get, and that's going to try and retrieve this database URL from a value in the environment. And what we can do in Python is we can check to see if the database URL has not been set with an if statement here. And if we don't have a database URL, what I'm going to do is I'm going to call logger.critical. So when you want to log out a critical error or a critical event in the application, you can use the logging package's critical level. And as with all levels, you give it a message, and the message I'm going to pass here is that no database URL was available. Now, when you have a critical event such as this, your application is typically not going to be able to continue. So what I'm going to do here, just to demonstrate, is call sys.exit, and we pass a status code into that. Now on the terminal at the bottom, I'm going to try and run this file, and the file's called app.py. So let's try and run that, and we're going to see that output here. This is the log entry, and it has the level critical here, as you can see. Now what we can do, if we run the script, we can actually set that URL. So what I'm going to do is set the database URL to a dummy value, let's say XYZ. And then after setting that, we can then run python app.py. We're not going to get the output in this case because that variable is actually set in the environment when we run the script. So in an application that depends on some configuration, if that does not exist, you can log a critical message to indicate that to your administrators. And of course, if you send the logs to a service like BetterStack, you can also configure alerts to be sent when you get these types of events. Let's now move on, and we're going to look at the error log level. Now the error level is used to log errors that are unexpected but do not necessarily cause your application to crash and exit. Events at the error level, they highlight issues that need attention, but that can possibly be handled and allow the application to continue running. So what are some examples of error events? We might have network communication errors or timeouts, and other errors can include things like trying to decode JSON data from an API, but that's failing because the data is perhaps not in the right format. Another example of errors might be a database constraint violation. So imagine trying to insert data, but you're trying to add a foreign key that doesn't exist. That's going to cause a constraint violation. And another example is when you try and access a file, but you might not have the access rights for that file. We're going to look at this exact example now. So what I'm going to do is go back to VS Code, and I'm going to remove the code from before with this database URL. Now on the left hand side, we have the app.py file. And underneath that, I have a document.txt that just contains some sample text. If we execute the ls-la command in the terminal, you can see the document.txt file. Now this document has an owner of root, and that's a different user from the one with which I'm executing these Python commands and running this script. So what we're going to do is we're going to create a reference to that file name, and we're going to try and open the file. And we're going to try and read the contents of that file and print them to the terminal. So the code we need to do that is here. We open the file as f, and then we call the file.read function. Let's save this and execute the script at the bottom, and you can see the output that we're getting here. We're getting a permission denied error, so we cannot open that document.txt. Now let's see how we can handle this using Python and using the logging package. So we're going to wrap this in a try except block. So let's do that just now. So we're going to try and open this file, but if we get any kind of exception here, we're going to catch that exception. And in that case, what we can do is we can call logger.error. So we're outputting a message with the level of error. And let's pass through a message here, permission denied when reading the file. So hopefully if we expand the terminal here, when we execute this again, what we're going to get is that error message instead of the exception, and that's what we get now. Now this might not necessarily cause your entire application to crash or make it unable to function. What we can do here, if we don't get the information from the file, perhaps we can create a fallback, and therefore this is not necessarily a critical error and we output at the error level. But of course, even though we can continue, this is something that is probably going to need to be dealt with. If you have a file on the server that you need to read, but that file doesn't have the correct permissions assigned or the correct owner, that's something that you're going to need to address at some point. Let's move on to the next level, and that's the warning level. Now, warning logs are used to indicate potential issues or issues that might lead to problems in the future. And these warning events, they don't necessarily stop your application from functioning, but they are events that will require attention in the future and should be addressed as soon as possible. And here are some examples of events that might be logged at the warning level. You might have outdated configuration settings. This might not prevent your application from running, but you should log these kind of things at a warning level to let people know, and that can be addressed as quickly as possible. Another example might be excessive resource consumption, and warnings can occur due to user actions as well. For example, an excessive number of failed login attempts. If a user is trying to log in to your site and they've tried that like 50 times or something, you might want to log these things because it indicates a potential problem. Another example is if you're sending requests to an external service and the response is taking a long time. And even things like expired tokens and certificates, these can be logged at the warning level. So let's show an example now in Python of something that might trigger a warning and how to handle this and log it to our loggers. Let's open VS Code again, and we have our file open here. What I'm going to do is I'm going to import a package that's deprecated in Python's standard library, and that's the telnet lib package. Telnet was a communications protocol, or it is a communications protocol, but it's not a secure protocol, and it's considered to be outdated and shouldn't be used. Now if we run this Python application, you can see we get this deprecation warning. The telnet lib package is deprecated and it's slated for removal in Python 3.13. Now what I'm going to do here is I'm going to wrap this in a try catch just to show how we might catch a warning here, and I'm going to use the except statement to catch that deprecation warning. Now because we're importing telnet lib and we're aware that this is a deprecated package, what I'm going to do is add a call to logger.warning, and that's another log level method that's available on the Python logging object. And let's add a message here of telnet lib is deprecated. If we execute the script at the bottom, we get the warning output just below the message from Python itself. So that is going to send this warning to all of the handlers that are configured. So if your code has a module that's importing a deprecated package, then you can use the logger.warning to tell the administrators and tell the developers about that. But again, this is not going to break your application at the moment. So let's move on now and look at the info log level. Info logs are used to capture general information about an application's operation. And these informational logs, they provide a high-level overview of the behavior of your application. And they help developers and administrators understand the flow of the application, how it's working, and any changes in state that might be occurring. And production systems are typically logging at this level, and that's so that the developers and the people involved in the application can build up some knowledge of how the application is running, and they can see the normal behavior of the app when they look at the logs. So what kind of events might you want to log at info level? One example might be a change in state in the application. For example, if you have an ordering system, if an order was to change state from in progress to delivered, that kind of change in state is something you might capture at the info level. Another example might be the successful completion of a scheduled task, or when you've successfully completed a connection to some kind of component that the application works with, for example a database or a cache or any other kind of system. And of course you might want to also log general information about requests and responses. And we mentioned a cache before. You might also want to log information about when you have a cache hit or when things have been evicted from the cache or are not found in the cache. So lots of examples of things that you might want to log at the info level. Let's provide a very simple example now. And what we want to do here is we want to send an HTTP request to a service that's going to return some JSON data. At the top, I'm going to import the requests package. And then just below the logging code, I'm going to create a function called getUsers. Now in this function, I'm going to reference this endpoint, and this is a URL from the JSON placeholder website. And we're going to create a variable called response, and we're going to use the requests.get function and pass that endpoint in. Now we don't know the status code of the response, so I'm going to use a try except block here, and we're going to call a method called response.raiseForStatus. And if the response status is not beginning with 200, then this is going to raise an exception, so we can catch that exception. So I'm actually going to paste that in here. It's actually a requests.http error. We're going to catch that, and let's say we get an error. We want to use the logger.error method that we saw earlier on, and we can pass a message into this. So I'm going to say request to endpoint failed with the given status code. Now at this stage we want to return none if we are unable to get a response from this endpoint, but in the event that we do get a response, we can log that out with the level of info. And I'm going to pass another f string in here and say that the request to the endpoint was successful. And finally, this is a function in Python, so we can return the data. If we know we have a response from that endpoint, we can take the response and call the .json function. So let's now call this function, and then we can run python app.py at the bottom, and we get the output with the level of info. So the request to that endpoint was successful, and we got a valid response there and converted it to JSON. Let's change the endpoint here a little bit so that we get an invalid response code. So I'm going to add some characters to the end of that when we execute that request. This time we're getting back the log with the level of error, and that indicates that the response was not valid. So that's an example of how you can use info logs and error logs together in a function in Python, and which one you use depends on the behavior of the function. Let's now move on to the next log level, and that's the debug level. Now the debug level, as the name implies, is useful for debugging and for general information and very granular and detailed information as you develop applications. It's not typically a level that's set on production when you deploy your apps, but it's very useful during development to trace the flow of your application and get important information such as the value of variables at particular times. Now it's not normal to have debug in production, as I just said, and that's because this results in a lot of logs being sent to your log services, and this can increase the burden on storage and disk I/O, especially if your application has a lot of users and a lot of requests and responses, let's say. So what might be logged at debug level? An example might be database queries that are being sent to your database from the application layer. We can also log details of API calls and response data at the debug level. And when we're setting up the application and setting up new services, logging out configuration values can be helpful for debugging and for diagnosing any problems that might be occurring. And finally, you might also want to log out some timing information at the debug level, and that can include some basic profiling of your application code, so timing how long a block of code takes to execute. Let's now see an example of debug logs, and I'm going to go back to VS Code for this example. And we're actually going to extend the example that we had for the info level, where we sent a request to a JSON placeholder. So let's say we have the successful response here. What I'm going to do is I'm going to convert that data to a Python dictionary before I return it. And we are interested in seeing what is this data, what does it actually contain. And again, you don't want to have this in production because let's say you have 1,000 users, you don't want to be logging out the entire response data every time one of these responses is coming in. So this is something that might be useful in development only. So underneath the data, I'm going to add a call to logger.debug, and I'm going to add another f string in here, and we're going to print out the response data from the endpoint. So we're adding that data in here, and we're going to log that at the debug level. And finally, we need to also return the data from the function. So let's save this, and we're going to go back to the terminal, and I'm going to execute this command. And we're getting a 404 not found here, and that's because I changed the URL at the top. Let's change that back and go back here and try this again. And this time you can see we're getting the debug logs that contain the data from the response. If we scroll to the top of that, you can see the log level of debug here. And we also have the info log above that, which comes from this statement here. So again, we don't want to be printing the response data every time this happens in our application in production. So this is something we do in development when we need to do a bit of debugging. We need to look at what is the response data in this case. That's the purpose of logger.debug, and that is this example that we've seen here. So let's now move on. We're going to look at the final level, and that's the trace level. Now trace logs are even more detailed than debug logs. And trace level logging is not as commonly used as logging at the debug level, and as such it's not supported by some logging packages and frameworks, and that includes the Python standard library. Its logging module does not include a logging.trace level. So why would you use trace logs? These are typically reserved for extremely detailed information, and this information might be useful in diagnosing very specific or very intricate events that are occurring in your application. Now, as I said, the Python standard library doesn't include a logging.trace method, but there are external packages in Python, such as LogGuru, which do offer this functionality. Now, for more information about the trace level, you can check out the BetterStack guide on log levels, and there is an example on this site that uses the Go zero log package. And as you can see, that particular package does include a trace method for the trace log level. So that's all the main log levels. We've covered some examples for each one of those. Let's finish by covering some additional information on log levels. And for this, I'm going to largely reference the BetterStack guide that we have here. We're going to cover the final 3 points. Let's start with the one at the top here, controlling the application's log volume. So as it says here, log levels, they provide a means to regulate the amount of log data produced by your application. And by setting the appropriate log level, you can determine which log entries can be recorded and which should be ignored. And this allows you to balance capturing essential information, but also avoiding an overwhelming flood of logs. Now, it's common, as it says here, to set the default level to info. So when you're in production, that's typically what you're going to use, but in development, you might want to set it to debug or trace. And whatever you set your level to, any level that is not as severe as that, these logs are going to be discarded, and that can help you control, as it said earlier, the amount of information that's coming to your logs. And on the left hand side, we have an example here of creating and using custom log levels. So you might have an example if you're building a large application where you need to include a custom level. And this is supported by some packages, for example, the 𝗵𝗄𝗃 package. You can use 𝗵𝗄𝗃 if you're doing logging in a Node.js application. And we have a video on 𝗵𝗄𝗃 that should be appearing on the screen now. And in that video, we have an example of how to create a custom log level for your application. So if the default levels that we've covered in this video are not enough, you can add your own custom levels for particular events. Now, the final thing I want to cover is the use of log levels for monitoring and analysis. So once you've developed your application and it's in production, and you've added logging statements with the correct levels to that application, the question being asked here is, how do we use those levels for proper analysis of the logs? And this gives 3 examples. The first one is filtering and searching the logs. So I'm going to show a demo here on the BetterStack logtail. I've generated a bunch of logs here, and they have different levels. You can see info, error, critical, warning, debug, and so on. Now what I'm going to do is I'm going to try and filter these logs by a particular level. So let's say we only wanted to find the errors. Let's click on error and we get back only the logs with that particular level. So by adding proper levels, we can filter the logs that we have in our services, and we can find only the ones that we are actually interested in. And each level is associated with a severity, and you can see if we expand one of these logs on the BetterStack tail, the level of error is associated with a severity level of, or a severity number of 4. So what we can also do is we can do other searches here, other filtering. So we can look at logs that have a severity that are greater than or equal to 4. Now if we execute this search, you can see we get back not only the error logs, but also the critical logs, and that's because critical is the log level with the highest severity, so we also get that back in the results. You can see how easy it is to search and filter logs when we have these levels set up appropriately. Let's go back to the BetterStack article, and what we can also do when we have levels properly set up is we can create alerts and do alerting in our applications. So let's say you're sending your logs to BetterStack, and when a log entry comes in with the level of error or critical, you can trigger alerts to occur and send notifications to specific users when these events happen. An example of that might be just sending an email to admins when you get a critical error in the application. And this allows the relevant people to be notified immediately when these kind of issues occur in your production environment. And the final example on the blog post is the ability to calculate various metrics. Now, an example of this might be that after you deploy an update to your application, you might see a significant increase in error or fatal/critical logs. And this may indicate that you have underlying issues or bugs that require attention. If you have some analysis and dashboarding set up on BetterStack's log service, you can quickly detect when this is happening, and again you can take steps to immediately resolve these issues. So log levels have many uses. You can see how they can be used for alerting, filtering, searching, and also for analysis. We've covered all of the main log levels in this video, but we've also noted that you can create custom levels using many logging packages. And that is all for this video. If you've enjoyed this video, please subscribe to the BetterStack channel. We have lots of exciting content coming up on topics like Docker and Kubernetes, testing, task scheduling, and also browser automation. Lots of things coming up. Please subscribe to the channel if you're enjoying this content and give the video a thumbs up. And we'll see you in the next video.